So down there is the nasty drain I used to film the LP838 review, and over here's our washing machine. And over here's the power point I used to power the light, which made that nasty drain a bit less entirely dark and invisible. And I had to unplug the washing machine in order to get to it, and plugging it back in, it seems to have turned into a Counter-Strike bomb. So we're going to have to take this machine apart and try and figure out what's wrong with it, because we don't have a spare, and yeah, it's entirely non-responsive. It's usually just always said a beep once and it's gone to standby. Now it's a bit of an odd issue, because even if I unplug it, it keeps beeping for quite considerable time. So normally when you see something like this, you go, oh, there's going to be a capacitive drop in the power supply, it's not going to be able to start because the cap's gone bust, and you'd replace that and be all gone. But the fact that it keeps going suggests to me that we've got ample supply voltage, because the capacitor that's just keeping everything running obviously has enough charge in it to keep it rebooting and rebooting and rebooting and rebooting. So either this thing has a bit of a more fancy power supply than that, or there's something more devious wrong with it. It is a relatively new machine, probably 5 or 6 years old. Does have a label. Made in Korea, it's a model WD12231TB. No real date code there though. So I'm just going to have to rip this thing apart and get the PCB out and have a look. One ASUS branded work light installation later, I've got the machine somewhat disassembled. It's very easy to get apart. It's just a couple of screws in the corner, so the entire top of the machine slides back and lifts off. And we pretty much have a view of all the electronicsy stuff in here, and this certainly looks quite a bit more high-tech than I was anticipating. So this is definitely going to be a switch mode power supply. But yeah, we've got a primary cap there, some little tiny caps there, could be, look to be primary, oh no, they're probably secondary side since they're on the other side of that transformer. Lots of little electrolytics all around really. So, not control related, it's a capacitor issue, but we've also got big black heatsink there. And I'd wager there's some horrible proprietary SDK type module stuck underneath it, and if that one's done for, then this board is done for, and perhaps the entire machine. But yeah, I think the first course of action is going to be to just heat this board up and see if it starts, because if that brings it back to life, then it's likely to be a capacitor issue, probably one of these small tiny ones, so, or perhaps even a solder joint. It's going to be annoying working on either way, because we've got everything potted in this really thick, goopy potting compound, which probably does a very good job at keeping the water out, but yeah, that's about all the good it does. Yeah, heating time. Alright, the board is now nice and warm, and I've gotten myself an energy meter, so let's see what happens. Oh, did that do the trick? It did have a bit of a struggle, but yep, we're back online. So that's great news. That means it's highly likely that we've got a bad cap in there, and we've got a red LED showing us when it's on. Excellent. So yeah, it's probably going to be one of the little boys. Could even be a relay in there. There's a little tiny relay there, which made a little rattly noise, which I didn't quite fancy. But yeah, I'm pretty certain that the issue is going to be on that board, and it's going to come out either way. And the entire front panel module pops out quite handily with the front panel PCB, which is just one of those cheapo boards, and the big power supply on the back. But the horrible part about this is that this entire thing is potted into the plastic, and you can peek in through these little holes there, and there doesn't seem to be any gap, any opening in this white plastic on the underside of the board. So basically I'm going to have to carve this entire board out in order to be able to probe anything. We do have access to probe a couple of these caps since they're mounted not flush to the board, so I might just do that for starters, but yeah, this is not going to be fun if I have to actually replace anything. As for the board itself, it seems to be a number 6871ER9010A, Euros BLDC, and apparently, yes, dated 2006, so it's pretty much 10 years old, this machine, and it's been sitting connected to the grid for pretty much all that time, so I suppose you really can't fault it for finally giving in. Anyway, I'm gonna probably be back once I've carved all this crap out, back in a few hours. Alright, a few calculated cuts and a vigilant attempt to cut the rectifier diodes in half. Thankfully a failed one. Later I have been able to find a probable cause for the failure. This capacitor, which is right here, this one by the top 234 or something. Oh, what's that I see? A top 243 YN. Heating this thing will basically cause the machine to boot instantly, and it's right by the power LED. So I'm hoping that that's going to be the issue. There are some Xenon diodes and stuff in there which could also be part of the issue, but I used a very tiny nozzle on the hot air rework station, and yeah, this capacitor seemed very likely to be the culprit. It actually measured quite fine. It's a 47 microfarad 35 volt, and you know, testing it on the capacitance and ESR meter, it pretty much checked out. At first I figured it's not going to be the issue, but I replaced it with a 100 microfarad low ESR proper cap, and I guess we're just going to have another test. If that one proves to be the issue, then I'm probably going to have to replace these three as well, because they're identical as to that one. Although I have probed these a bit, and they too seem to check out. Did I make a hole? No, I didn't make a hole. But yeah, these seem pretty okay. This is a 130 microfarad 25 volts, and I think these two are 470-35. Yeah, 470-35, Samyang brand, all of them. Which isn't too bad of a manufacturer, to be honest. But yeah, let's test this board again with a new cap there. Alright, the board is at room temperature and everything should be connected, so let's go. Boots up perfectly. I'm not going to touch this. I'm not certain if it's live at mains or not. Probably not, but yeah, that's a pretty good improvement. No startup issues at all, not a hint. And that red LED is staying lit quite a bit longer. Let's try it again. Yep, we're gonna have that was the issue, no doubt about it. So that means I'm gonna have to make another hole in the plastic and replace these three caps as well, because I'm not going to trust them. And there we go. I just repotted everything with hot glue. We'll see how well that works, and stuck some parts of the original plastic back where they came from. It's not pretty, but you don't have to see this anyway. So we have the new caps, all 47 microfarad, and we'll have to see how well that potting compound really holds together. There doesn't seem to have been any real moisture issues in this machine though. There's no trace of corrosion on the board, which is not on the control board, which is not potted at all. So I don't think we're going to have any issues. It's going to turn out quite alright. So all I've got to do is just mount this back together and order more hot glue, because this consumed a lot. And on a somewhat unrelated note, something which just struck me as a bit odd is that this board does have this very charred looking resistor right by a few of these multi-pole connectors, and at first I figured that would be a considerable part of the issue, but it measures relatively okay. It should be 330K from what I can see in the markings, and measuring across it doesn't give you a result above that, so
I don't think this resistor is actually an issue. Why it's burned though is anybody's guess. I really can't see. If it's going to become an issue in the future, I guess we'll find out, because I still haven't tested if this machine will actually still run. There could be some follow-up issue from it just going in cycling like that, or having excess ripple on that power feed, but that remains to be seen.
Oh, there we go, all put back together, save for the top. I took the opportunity to clean out all the crud out of it. There was literally a decade's worth of just crap and crust stuck in there, and all the pipe work, and let's just say that there was a lot of shit coming out the front of the drain down there. So I think this machine is going to do a quite good job at cleaning in the future if it decides to start working now. So everything should be back together. There shouldn't have been any water on the electronics, since I didn't have any when I did the cleaning. It's going to be pretty drenched down there, but I'm pretty sure there isn't any actual stuff in there. It seems to be just the bottom of a drum. But who knows, it might explode. Let's just give it a go. Where's the power cord? There's the power cord. So it should say beep once and start up for us. 2 watts standby consumption, not too bad for a 10-year-old device. So it's going to run. That looks pretty good. Oh wow, that looks so bad on the camera. Jeez. Let's just let it run a 95-degree empty cycle to really finish the cleaning out. No centrifuge. And yeah, let's see what it does. Bang. Oh, that's no water supply. Righto, take 2 with water. That's better. Pulling it up through the nicely cleaned out supply, and it's, yeah, they're gonna be able to see it. It's running the drum, filling it up. It's probably gonna drain it up pretty soon. Well, that looks excellent. So in 1 hour and 33 minutes we're gonna know whether or not this is a fix. And it just finished its cycle. Is the hatch unlocked? The hatch is unlocked, there's no water inside. And I'd say this machine is working excellent now. So all remains to do is fiddle this thing back on, like so. Put in the 2 screws and call in support to get it back up there. As far as the original capacitors go, they're really not too bad. This is one which caused the failure, which is at 1 ohm and 44 microfarad. If we probe on the others, they're about the same. And normally I would say that an ohm for a 47 microfarad is, well, it's a bit on the high side. But it's certainly not entirely bad. And if we have just to grab one brand new out of a box, a Nichicon PS 47 microfarad 50 volt, it's not going to be too far off. About 800 milliohms and 49 microfarads, so that's not a huge difference at all, really. As far as impedance is concerned, I'd basically rate these capacitors identically. I mean, it's pretty much within the margin of error. And it's warming up from my fingers. So, I don't know. It must be that either something else has drifted in spec in that machine, perhaps that a power resistor, or it's just been designed so just at the limit that as soon as the capacitor dropped from 47 microfarads, bang, it's gone. But either way, there's 100 microfarads there now, which should not be an issue for quite a considerable amount of time in the future if that's the case. So, thank you for watching. Cheerio.